Hello and welcome to this section 5.1 lecture. Today we're talking about writing linear equations from situations and graphs. So we've worked a little bit with graphing in slope-intercept form, and now we're actually going to be writing these equations into slope-intercept form based on whatever information is given. So this first one says that Greta makes clay mugs and bowls as gifts for the crafty studio. She pays membership fee of $15 a month and equipment fee of $3 an hour to use the pottery wheel, the table, and the kiln to prepare these pieces of pottery. We want to write an equation in the form y equals mx plus b that Greta can use to calculate her monthly costs. So the important thing here is to kind of dive through the information a little bit. Let me just make sure that I'm all squared up, and I'm not, so let me fix that just here really quick. Come on. And 3. Okay, now we're good to go. So looking at kind of highlighting the information, and sometimes it's handy to use a highlighter to do this. We have $15 a month and $3 an hour. Okay, so obviously her how much she owes is going to be based on how many hours she's there throughout the month. So this first one says, what is the input variable x in this equation? Well, it's how many hours she works there or uses their services. It's the hours. Okay. The output variable y is how much it's going to cost her. So cost, I'm going to say cost to Greta. So we know we're not talking about the cost that the studio has, but how much Greta owes at the end of the month. It says during April, Greta does not use the equipment at all. She might go in there and I don't know, paint some of the pottery or whatever it may be, but she's not using the wheel, she's not using the table, she's not using the kiln. So she's not building any new pottery. And maybe she's not even going there at all. She's just a member of this studio, and she has a busy month. Okay. So what will her hours be in April? Well, she's not going there at all. She's not using their materials, so it's $0. But she still owes money for her membership fee. She still owes $15 for her membership fee. So what we've just shown here is that x is 0 and y is 15. So if we were to graph the equation of her studio usage versus her cost, this point would be 0, 15. Which makes that the y-intercept, right? That's what we talked about. The y-intercept is the y value when x is 0. So her y value, or her y-intercept is 15. It says Greta spends 8 hours in May for a cost of 15 plus 8 times 3. And so her cost is 8 times 3 is 24 plus 15 is $39. That's how much it's going to cost her in May. In June, she spends 11 hours, so to calculate that, it's going to be the 15 plus 8, not 8, sorry, 15 plus 11 times 3. 11 times 3 is 33. 33 plus 15 is 48. From May to June, the change in the x values is, well, from in May, she used 8 hours, and in June she used 11 hours, so the change in the x is 3, or 3 hours. And then change in the y values from 39 to 48 is $9. So the slope is the y values over the x values, or $9 for every 3 hours. And 9 divided by 3 is $3 for 1 hour. We want to use the values for m and b to write the equation. So we have b is 15 and m is 3. So we could write this as y equals 3x plus 15, where x is the number of hours and y is the cost. Okay. Writing an equation from a graph, we can do the same kind of thing from a graph. We just have to find some of the information that we've talked about. We need to find the y-intercept and find the slope. So this one's already done for us, but let's go ahead and read through it and see if we can kind of get a hold of the information a little bit better. A video club charges a one-time membership fee, so you might think of this as like Netflix. Okay, the not the streaming Netflix, but I want this video to come in the mail. Okay, and that's kind of how this works, sort of. Choose 2 points on the graph, x1, y1, and x2, y2 to find the slope. So they use the point 0.8. Let me switch colors. They use the point 0.8 and 8.18. And they picked those because these 3 points here weren't true grid points on the graph. We don't really know what this y value is. We don't know what this y value is or this y value. But these two we know. We have 8 and 18 for y values. So they plug those in. And, you know, if I were looking at this, I would say, well, we have 0.8 and 8.18. So I'm treating this as my x1, y1, and x2, y2. y2 minus y1 is 18 minus 8, which is 10. And x2 minus x1 is 8 minus 0, which is 8. And 10 over 8 simplifies to 1.25. Also, we can tell the y-intercept on the graph. It's right here at 0.8, so 8 is my y-intercept. Okay, so using our slope and our y-intercept, plugging it into y equals mx plus b, y equals 1.25x plus 8. So it's like an $8 monthly fee to be part of this program. And then for every DVD that's rented, it's $1.25. So what does the value of the slope represent in this context? Okay, so I just answered these two questions. The value of the slope means they charge $1.25 per DVD rented. And the y-intercept, there's an $8 monthly fee. So again, kind of like the Greta problem, if they don't rent any DVDs here, the company is still going to get some money from them. They're going to get $8 from whoever is a part of this club or this group. So it's just a way that they can make money even if you don't rent any DVDs. Let's try this your turn problem. It says the cash register subtracts $2.50 from a $25 coffee cafe gift card for every medium coffee the customer buys. Write an equation to represent the slope. To write an equation in slope-intercept form to represent the situation. So the gift card starts with $25 on it, and we're assuming that this person only buys coffees or anything that costs $2.50. So every one coffee that's bought, the amount goes down $2.50. So we would say that the Y-intercept on this is 25, because it starts with $25, and for every coffee that's bought, they take off $2.50. And we can write 250 as 2.5, where X is the number of coffees and Y is the amount that's still on the gift card. And then we do see from the graph that after 10 coffees, they're out of money on the gift card. Write an equation from a description. So we can do this just as easily. And so this one says that we have the rent charge for space in an office building is a linear relationship related to the size of the space that's rented. So we have a couple situations here. We have a 600 square foot location for $750 and a 900 square foot location for $1,150. So we're going to use those as points. Okay, and that's what they're doing right here. They're using X to represent the size and Y to represent the cost. Almost always when you're representing equations, you want your Y value to be the cost, because it shows how high, it shows vertically how much it's going to cost, and people are just a little more comfortable with, seeing that, oh, I've bought this many things, it's going to cost me this much money. Okay. And so to do that, we're going to find the slope. We're going to go x1, y1, and x2, y2. So we're going y2 minus y1 is 400, and x2 minus x1 is 300. So it's 4/3 for our slope. Then we need to find the y-intercept, and that's sometimes a little bit tricky because they don't give us any scenario that would find the y-intercept. So I'm going to sort of redo this and talk through this, but you can see it here as well. Okay, this involves a little process of solving equations. Okay, we want to solve for the y-intercept, and we don't know it, but we know our 2 points. So I'm going to fill it in my notes here. I know that I'm starting with the equation y equals mx plus b. Okay. And I know my slope. I found my slope. So I have y equals 4/3 x plus b. Keeping in mind what I want to solve for. I want to solve for b, and I have these 2 points. So you can pick either one. They picked the easier one, 600 and 750. I'm going to pick the harder one, just to show that we get the same thing. 900 and 1150. So you put the x in the x and the y in the y. So this y value is what I'm starting with, 1150 equals 4/3 times the x value, 900, plus b. And I don't know what that b is, that's what I'm trying to find. So multiplying this, I'm going to get, looks like 4/3 times 900. I can do a little bit of cross-reducing. And it turns into 4 times 300, which is 1200. So I have 1150 equals 1200 plus my y-intercept b. And now to solve for b, I do need to subtract the 1200 from both sides. Just making sure that we're getting consistent results. So when I subtract 1200 from 1150, it gives me negative 50. Subtracting 1200 from 1200 gives me 0. And I have b equals negative 50. So technically, if you bought a 0, or if you rented a 0 square foot space, they would owe you $50. That's probably not going to be the case, but that's what this is saying. So then we rewrite our equation. So we got that negative 50 for a y-intercept. We got 4/3 x minus 50. Without graphing, tell whether the graph of this equation rises or falls from left to right. And what does the sign of the slope mean in this context? Okay. So since it's a positive slope, 4/3, the graph rises from left to right. So the graph will rise. And since the slope is basically the cost per square foot, that means that the positive slope means the company, the rental company, charges more for more square feet. We use square feet written that way. Okay, for more square feet. So the bigger the space, the more it's going to cost you. That's kind of what we're getting at there. Okay. And we've got one more little U-turn problem here, and it's probably going to involve finding the y-intercept. So I do want to do it, but they don't give you very much room to do so. This is Harry's weekly allowance varies depending on the number of chores he does. Pretty typical situation. He received $16 when he did 12 chores and $14 when he did 8 chores. So first we need to find the slope. And so we're going to go, for my x's and y's, we're going to go number of chores for x and allowance in dollars for y. So I get the 2 points. He did 12 chores and got $16. And he did 8 chores and got $14. So we can find our slope, x1, y1, x2, y2. So my slope is going to be 14 minus 16 over 8 minus 12. Okay, 14 minus 16 is negative 2. 8 minus 12 is negative 4. And so I get 1/2. That's what that reduces to. And a negative divided by a negative is a positive. So I've got a slope of 1/2, which basically means he gets 50 cents for every chore. Okay? Or if you were to think of it this way, so we think of the numerator on the slope as y, so that's $1 for every 2 chores. Maybe that's an easier way to think of it. $1 for every 2 chores. Okay? But now I have to find my y-intercept because they don't give that to me. I know that my equation is going to look like something like y equals 1/2 x plus or minus something, right? And whatever my y-intercept is, for now I'm just going to say that it's plus b. But I'm going to replace that here in a second. So I'm going to pick a point and plug it into this equation. And when you're picking points, pick one that works better if you can, to make the math a little bit easier. So I've got 14. I'm going to use 814 here. 14 is the y value. 1/2, 8 is the x value, plus b. Do the multiplication. 1/2 of 8 is 4. And to solve for b, I'm going to subtract 4 on both sides. On the right side, my 4's go away. On the left side, I get 10. which means we kind of think of B as like a base value. It's the amount that I'm guaranteed to get. Okay, or I guess Harry is guaranteed to get. I wish I got $10 a week. That'd be nice. Nobody's ever going to complain about an extra $10 a week. So then all we do is we just replace that in where our B is, and we're good to go. So the equation that models this situation, y equals 1/2 x plus 10. So he's getting $10 as a base amount, and then for every 2 chores he does, he's getting an extra $1. That's what this whole equation says. Okay, so that'll be it for today. Last thing we need to talk about is our code word. We're going to go with allowance. Let me use a color I haven't used yet. That's going to be my code word for the day. Okay. Hopefully that helped. I understand if this last example is a little bit difficult. We will probably be taking an extra day just to work on that. But the original part where I, in essence, give you the slope and y-intercept, or at least give you the y-intercept and another point, that should be more manageable. If you have a hard time with that last example, that's okay. We're going to be working on that. That being said, have a great day, and we will see you in class.